Good morning, students. Welcome to Ramsudhir's IAS Academy. We are back with a new video on time and work part 2. We have already made a video on time and work part 1, so this is the second video in the series. We'll move on to solving our questions. Before solving our questions, we have to keep in mind the important formula in solving questions related to time and work, which is this formula, which is efficiency equals to work by time. This is a formula which will help you sail through time and work, my friends. So this is the only formula you should remember, so keep it in mind. Now moving on to the questions. We'll solve somewhat complex questions in this video, as students have asked me to solve complex problems, more complex problems than they were in the previous video. So we'll move ahead. Question number 1. A and B can complete a piece of work in 15 days, B and C in 12 days, C and A in 20 days. If A works on every day and B and C help on every alternate day starting with B, find in how many days the work will be completed. Now, the main part in solving the question is that you should just understand the question, my friends. Understanding the question, half the work is done. Now, moving on to solving the problem. First, I'll just write my given data. A plus B takes 15 days, B plus C take 12 days, C plus C take 20 days to complete the work. Now, my immediate next step would be solving finding out LCM for this, which will be my units of work. The LCM turns out to be 60, which is my units of work, and then I move on to solving my efficiency using the formula efficiency equals to work by time, and I get the efficiency of A plus B to be 4, B plus C to be 5, and C plus A to be 3. Now, moving on to the question. If A works on every day assisted by B and C on every alternate day, it means that A is working on the first day, A is helped by B, and on the second day, A is helped by C. And on the third day, again A is helped by B, and on the fourth day, A is again helped by C. That's the question. That's what the question is asking for. Now, in how many days the work will be completed in such a manner? So, in 2 days, 7 units of work is being completed, my friends, and on the next 2 days, 7 units more the work is being completed. So, for finding out a solution, the time taken to complete the 60 units of work, we'll assume a multiple of 7, which is near to 60. And a multiple of 7, which is near to 60, is 56. I mean, it's 7 into 8, which is 56. So, to complete these 56 units of work, it would take 2 into 8. I mean, the 2 from here. 2 days would take 7 units, and for the 56 units, it would take 2 into 8, 16 days. 56 units of work is completed in 16 days, my friends. And then remaining 4 units of work is left. Like after 60, after performing 56 units of work, 4 units of work is remaining, and this 4 units of work is completed by A plus B, because A plus B complete 4 units of work in a day, because their efficiency is 4. They complete 4 units of work in a day, and totaling up, they give us 60 units of work. Therefore, 16 plus 1, the 60 units of work will be completed in 17 days, which is our answer. I think the problem is okay with you. Moving on to the next question. A, B, C take 18 days to complete a job. A and B work together twice as C. A and C together work thrice as B. A alone how many days? Here the question is not that complex, my friends. Okay, it is complex in terms of the words used in the question, but here we are solving the question with respect to efficiency. There were days, I mean time given in the previous problems. Now we are solving the question with respect to its efficiency. Here it is given A plus B plus C would take 18 days, and efficiency of A plus B is twice as C. So writing it in the form of a ratio, efficiency of A plus B is to efficiency of C, it would give me 2:1 from the question. And second part of the question, efficiency of A plus C is to efficiency of B alone is 3:1. Now this is what given in the question. Now moving on to the solution part. Now summing up these two ratios, it would be 3, my friends, 2 plus 1, 3. And this is just a technique, and summing up these two ratios, 3 plus 1, this would give me 4, which is what I have written here over in the brackets. And just take LCM of these two, my friends. LCM of 3 and 4 would be 12, and I would multiply this 4 over here. I mean, like, to yield me 12. 3 to yield 12, it should be multiplied with 4. So this ratio will be multiplied by 4. And here the sum is 4, and 4 to yield 12, it should be multiplied with 3, and therefore this ratio is multiplied by 3. Our new ratio is 8:4 and 9:3. Both these ratios are similar, my friends, except the common terms are removed over here, and this would yield 2:1. So I have multiplied the common term, which is 4 and 3, which would yield me 8:4. Efficiency of A plus B is to efficiency of C is 8:4, and efficiency of A plus C is to efficiency of B is 9:3. Now, this would make our problem look easy, my friends. Now, I'll directly assume efficiency of B is 3, and efficiency of A plus C is 9, and efficiency of C is 4, and efficiency of A plus B is 8. This is the way to solve problems of such kind. Just add the ratios and then make an LCM and multiply with a constant number, and then obtain the ratios of higher products. And then I'll have efficiency of B to be 3 and efficiency of C to be 4 from above, and efficiency of A plus C is 9 and therefore efficiency of A would be 5, or efficiency of A plus B is 8 and therefore efficiency of A would be 5. Either ways efficiency of A will turn out to be 5. Now the question asks this: A alone would take how many days to complete the work? Now A plus B plus C would take 18 days and the efficiency of A plus B plus C is 12, my friends. Therefore the total work would be 18 into 12, which is time into efficiency. The total work would turn out to be 216 units. So A alone would complete this in 216 by 5, which is total work by efficiency of A. So A alone would take 216 by 5 days, which is approximately 43.2 days. Yeah, 43.2 days. This should be your answer. Got it, friends? Moving on to our next question. Yeah, sorry. Efficiency of A is twice efficiency of B. If both work together, they can complete the work in 12 days. Work can be completed by B alone in how many days? This is also a question on similar lines. We have efficiency in our questions. He is asking us to solve the time taken by B alone, or A alone in that matter. Now, efficiency of A is 2 times efficiency of B from question. I'll just suppose that efficiency of B is 1 and my efficiency of A turns out to be 2 from here, I mean from the question. Now, A plus B take 12 days and my total efficiency of A plus B is 3, my friends, and therefore my work would be 12 into this 3. Therefore, that would be 36 units of work is the work allocated to me, I mean A plus B. Now, there is total work 36 units and efficiency of B is 1, and the time taken by B alone would be 36 by 1, which is 36 days. This is the question asked and this would be our answer. If the question is asked how much time A alone would take in completing the work, it would be 36 by efficiency of 2, which is of A, which is 2. Our answer would turn out to be 18 days. I think you are done with the question, and there are no complex questions here, my friends. Just the word game in the question makes a problem look complex. It's just our understanding capability which would make our question solving easier. So moving on to the next question. And if you observe, I have solved every question on similar lines. There was no new technique adopted by me. So I think you could also solve the problems using LCM and the formula efficiency equals to work by time. So moving on to the next question. A started the work and left after 2 days. B finished the remaining work in 9 days. Had A left work after 3 days, B would finish the work in 7 days. How many days would B alone take to complete the work? I think you have understood the question, my friends. From the question, it is clear that when A is working for a day more, 2 to 3, when A is working for 1 day more, B is finishing the work in 3 days lesser. Like, it means that if A's 1 day work is equal to B's 3 day work, this is clear from the question. If not, read the question once again. And then this would imply that efficiency of A is thrice efficiency of B. Therefore, if I assume efficiency of B to be 1, then efficiency of A would turn out to be 3. And my total work would be A does 2 days work with its efficiency 3, this is 6. And B would work for 9 days with its efficiency 1, this would be 9, and our work would be 15 units. Or, in the second case, A is working for 3 days, and B is working for 6 days to complete the work. In that case, A is working for 3 days with an efficiency 3 and B is working for 6 days with an efficiency 1, which would also turn out to be 15 units. Therefore, our total work is 15 units. Either ways, we'll get the same units of work. So our total work is 15 units. Now, we are asked to find the time taken by B alone. Time taken by B alone is the total work divided by efficiency of B. Efficiency of B is 1, which we have assumed. So our time taken for B to complete the work would be 15 days. If the question is asked for time taken for A alone, it would be 15 by 3, because efficiency of A is 3, and the answer would turn out to be 5 days. I think the question is okay with you, and the solution is also done. And I think you are finding the solutions a bit easy now. So I'll move on to the next question. Next question. A can do a piece of work in 16 days and B in 24 days. And with the help of C, they can finish the work in 6 days. If the remaining work is for if total remuneration for the work is, this is remuneration, my friends, if the total remuneration for the work is rupees 400, find the amount earned by each. And this is not much different from time and work. This is just an application of time and work where the wages are divided between them. And remember, my friends, this is just a common logic that every person completing a work, I mean, if 3 students are completing a work, 3 workers are completing a work, or 3 laborers are completing a work, they'll be allotted the sum of money in the ratio of their efficiencies. I work more efficiently, I'll get more. If if some other person works less efficiently, he'll get less money when compared to me. That's the logic over here. Now, A takes 16 days, B takes 24 days, and A plus B plus C together takes 6 days. This is given in the question. I'll just go with my first step, finding out the LCM of 16, 24, and 6, which is 48, and our work turns out to be 48 units. And the next step, finding out efficiency, which is 3 for A, 2 for B, and 8 for A plus B plus C. I mean, A and C, A, B, and C together, the efficiency is 8. I have efficiency of A to be 3, B to be 2, and my efficiency of C would turn out to be 3. Now, the amount earned by each individual would be the efficiency, the fraction of their efficiency, like total efficiency is 8, and efficiency of A is 3, therefore the sum amount earned by A is 3 by 8 into 400, because the total remuneration is 400, and the sum earned by B is its efficiency by total efficiency into 400, and the sum earned by C is its efficiency by total efficiency into 400. So solving this, I will get efficiency, the remuneration by A is 150, B is 100, and C is 150. And observe here, the efficiency of A and C are equal, which is 3, and therefore their earnings are same, and efficiency of B is less than both A and C, and therefore it has earned little. Okay friends, moving on to the next question. I think problem solving has become easy for you with respect to time and work. There are no other questions which would be asked on this, and there is another question which is on in the later slides. Yeah, this is the question. 15 men take 21 days working 8 hours each day. How many days working 6 hours each day 21 women would take? And the condition here is if 3 women can do as much work as 2 men. It means the efficiency of 3 women equals to efficiency of 2 men. And this is our formula for solving such sort of questions. There are only 2 formulae, my friends, from this chapter, which is efficiency of work by time, and the second formula would be this one. Now, in question it is given that efficiency of 3 women is equals to efficiency of 2 men. Therefore, efficiency of 1 woman would be 2 by 3 men, and efficiency of 21 women, because the question asked for 21 women, efficiency of 21 women would be equal to the efficiency of 14 men. Of course, solving 2 by 3 into 21, it would give me 14 men, and this is our M2, my friends. And substituting the values of M1 D1 H1 and M2 D2 H2, we'll get these. And in both the cases, work is same, so I have assumed it to be W, which cancels out, and our D2 turns out to be 30 days solving this equation. I think you are done with this question, and every problem will be on similar lines. Problem with respect to time and work should go easy with you. Moving on to the next question. I have already discussed in an earlier video that pipes and cisterns is just a separate topic in various books, but it will be solved on similar lines with respect to time and work using LCM. Now moving on to the question. 2 pipes can fill a tank in 15 hours and 12 hours, and another pipe can empty it in 4 hours. If these pipes are opened at 8 a.m., 9 a.m. and 11 a.m., find after how much time the tank will be empty. This is also an application from pipes and cisterns. Solve it on a similar lines. And make sure you practice questions, my friends. Yep. A takes 15 hours and B takes 12 hours. C, which is emptying the tank, and therefore E in the bracket, takes 4 hours to empty the tank. Now my first step would be calculating work, units of work, which is 60, because the LCM of these turn out to be 60. And my next step would be calculating efficiency, which yields me efficiency of A to be 4, efficiency of B to be 5, and efficiency of C to be minus 15, because it is emptying the tank, and as per the convention discussed in the earlier video, emptying would be considered negative, and therefore the efficiency of C is negative, minus 15. And the total efficiency of A plus B plus C will get 16, my friends, cos 4, because it is 4 plus 5 minus 15, plus minus 15 equals to minus 6. This means that on there would be negative work, that is emptying of the tank is being done. Now, at 8 a.m., 9 a.m. and 11 a.m., 3 types are at 8 a.m., 9 a.m. and 11 a.m. Sorry friends, not simultaneously, at 8 a.m., 9 a.m. and 11 a.m. Now, 8 a.m. to 9 a.m., A is the only tap opened, so 4 units of the tank will be filled. And from 9 a.m. to 11 a.m., both taps A and B are operating. Therefore, A plus B, whose efficiency is 9, they are working for 9 to 11, 2 hours, and therefore 9 into 2 hours, which gives us 18 units. Summing up both these, from 8 to 11 a.m., 22 units of the tank are filled, like 18 units over here and 4 units from here. 22 units are filled from 8 to 11 a.m., my friends. Now, at 11 a.m., the tap 3 is also open. Now, all the taps A plus B plus C are working together at 11 a.m. Now, because the total work done by A plus B plus C is negative because the efficiency turns out to be -6. It is doing negative work. Therefore, from here, the emptying of the tank will be starting. Now, time taken to empty the tank is 22 units are filled. This is the work to be done by us now. And the efficiency is 6 because it is -6 and we'll consider 6. And emptying is done over here, which is 3 4 by 6 hours is the time. 3 4 by 6 turns out to be 3 hours and 40 minutes. And the question asked is, find after how much time will the tank be empty? It will be empty after 3 hours 40 minutes. And if he is asking for a time, for the time at which the tank will be empty, it is 2 hours 40 minutes PM. Like from 11 a.m. it would take 3 hours and 40 minutes. And therefore, 40 minutes, 2 hours, 2 PM. Therefore, that's our answer. And remember, my friends, in solving these questions, there are only a form time and the basic concepts of LCM which I have used. So make sure you also solve problems of certain type. All the types of problems from work time. Make sure you practice more number of problems that will make your work easy.